Okay, Edx M3 January 2011, question 2, on the topic of centre of mass. Here's the question. It's a cone, solid cone, joined to a solid hemisphere. So take some time to read the question by pausing the video, and then we'll get started. Okay, as usual with these questions, we need to make up a table showing the components of the object and their masses and the relevant distances. So the question saves us having to work out masses or anything from volumes in this case, because it tells us that the cone is a mass km, the hemisphere is a mass 4m, so the total is k plus 4m. That's that. The question also tells us that the centre of mass of the whole thing is at O. So if I'm filling this table up with distances from O, that's a 0. For the cone, from the formula book, the centre of mass of the cone is a quarter h above the base. Now in this case, the centre of mass of the cone and the hemisphere are on opposite sides of O. So for the cone, that's the centre of mass, and for the hemisphere, again from the formula book, it's 3/8 r from the centre of the hemisphere. So the hemisphere is 3/8 r below O, and the cone centre of mass is a quarter of 2r above O. So that hence the opposite signs. Now we take moments about O, or about the line OB, and 0 for the total mass at the centre of mass is minus km times 2r over 4, tidy it up in a moment, plus 4m times 3r over 8. And all we've got to do now is tidy that up. The m's cancel, and it gives us k equals 3. Take a moment to check that. That's the first part done. On we go. For the second part, I've already done a drawing. I just need to zoom out. That's better. So for the second part, a metal stud is attached at the tip of the cone, and the whole thing is suspended by a string attached to B, so it hangs as shown in this bottom diagram. And the angle between OB and the vertical, if you can just see it in there, a bit small, the angle here is 30 degrees. So I've drawn a bigger diagram of that, showing the line from O to A. Here's the 30 degree angle between OB and the vertical. Here's the mass of the toy at O, 7 mg, and here is the lambda m, the metal stud that we're hanging at A. So we've got to find the value of lambda. Now this is just a matter of finding these distances here, because we're going to use moments, take moments about this line here through G. So it'll be 7 mg times this distance will be equal to lambda mg times this distance. And those distances, that one and that one, are in the same ratio as h to k by similar triangles. So from the trigonometry there, h over r is tan 30, so h is r over root 3, and k, because the whole distance OA is 2r, k is 2r minus r over root 3. So taking moments then, about G, we get 7 mg times h equals lambda mg times k. As I explained, h and k are in the right ratio as this distance and this distance here. So 7 cancel out the m's, and 7 r over root 3 equals lambda over 3 I've done some tidying up to make this easier. 6r minus r root 3. Check what I've done there. I've just tidied up the k a bit, the k distance. So the r's can cancel out there, and lambda works out to be 7 root 3 over 6 minus root 3. And that would do, or if you feel like tidying that up further, again you can test yourselves on this. That's equal to 7 over 2 root 3 minus 1. Oops, that's gone a bit wrong. 2 root 3 minus 1. Okay, let's look at the marks for that question. I've only put it in that form at the end there because that's what it gave in the mark scheme. Right. So for this first part of the question then, for the table, the quantities in the table, there was a mark there and a mark there for putting the correct values in. Then there was a method mark and an accuracy mark for taking moments and getting the right value of k. For the second part of the question, there was a mark for getting these distances right, then a method mark for and an accuracy mark, a method mark and 2 accuracy marks for this bit, M1, A2. A total of 4 marks for that. Okay, that's it. Thank you for listening.